right. Well, I want to thank everybody for taking the time to come in and learn about passive monitoring access. I kind of want to start out by going over the flow that when I was putting together this presentation, it was kind of like, well, what do I want to tell you guys? Because I'm sure some of you guys are familiar with TAP technology and different methods of gaining access to your network data. I'd hope. And if not, you will be by the end. So I thought about some things that were absolute, that really never changed. I mean, we know tools change. They're evolving. There's always something hot out on the market. You've got the latest trade show. You've got the latest tools and technology, and everybody has to have them, and everybody's outdoing each other. Whoa. All right. Something remained consistent, though, and that was you have a network, and you have monitoring tools, and you need to somehow marry these together passively and never really trying to introduce a point of failure into the network. It's usually not a good thing. So I just wanted to, essentially from the people that are in the room, how many of you are dealing with, and I won't move too far away from this, dealing with port contention for monitoring? I mean, are you finding that you're running out of monitor ports and you're looking for a way to gain more visibility with additional tool sets? By a show of hands, anybody? You, definitely. Okay. As well, how many are using span ports as a means to gain access to data because you feel that that might be the only solution? And I'm not here to down span ports because I love them, but there's definitely needs sometimes to go inline at a physical layer, and passive access is definitely the way to go. Okay, so we have some. The rest of you, I know you're still monitoring your network. Basically what we're going to do is we're going to kind of go over a few sections. We're going to give you a brief. Is it me?
No, you're fine. You're fine. I feel like I overcompensated.
Oh, yeah, I was echoing a little bit there. We're going to go over a brief TAP technology overview. Can you still hear me? Okay, perfect. Kind of some of the things we've been doing probably up till now. Some of us, using hubs, using spam ports, putting devices in line. Some of the, advantages, disadvantages of those. And then talk about TAP or passive access technology and how you can use different tools to gain access passively. We're going to jump into more detail about specific products out in the market that are available for you, such as TAPs, port aggregation TAPs, and regeneration TAPs. And we're going to jump into some feature sets such as active response and where that plays a role in your monitoring and bypass switches. And then we're going to jump into link aggregation and matrix switches and really how to leverage your existing tool set. We know you have all these expensive tools. There's got to be a way to get leverage out of those and gain visibility across multiple network links. And then we're going to kind of wrap up with some TAPs with intelligence. So that should be really exciting because now we're going to see TAPs evolve into, or passive access technology rather, evolve into taking a snapshot or looking at statistical information on the network. I mean, heck, we have all of this data going through a passive access device such as a TAP anyhow. We may as well grab some statistical information, give you SNMP capabilities, remote access, and for traps and stuff on the SNMP there. Does that sound good? All right. So when we think about passive monitoring access, we really think about the fact that you should have full access to 100% of the packet data. So layer 1 errors, layer 2 errors, CRCs, things like that. You shouldn't have to really sacrifice losing that data if it's critical for you in your troubleshooting. Passive in the sense that you shouldn't incur any additional latency to put your devices out on the network and view this data. Shouldn't have any link failure. You shouldn't have any, additional packets. There should be no manipulation of the packets as they go through a passive access device. We understand that traffic can be collected in several different ways, and some of the ways that we've done this in the past up to now is using hubs, spam ports, putting devices in line. We can all probably remember a time where we've done that. And then taps, which is kind of the way to go. Something I want to cover before I jump into some of the different ways that we've captured data in tap technology or passive access technology is zero delay. I'm going to be using the term zero delay a few times throughout this tutorial, and what I want you to take away from zero delay is that fact that there's this feature in tap technology that eliminates the typical 10 millisecond delay that is found in most passive access devices out in the industry when the tap loses power. So if you think about it, you've got two end devices, you've got a passive access tap in line between power state change. Power fails, power comes back up after failure, something. There's usually like some sort of internal relay that's got to take, open or close the circuitry, and that's about a 10 millisecond delay. Now, obviously, depending on how end devices are configured, this could result in a longer delay as well if the link has to completely renegotiate. So zero delay is really a way for you to make sure that you can pull power from a passive access tap all day long and never disturb the network link, not lose a single packet on the network. You will find zero delay in 10100 copper products. Yes, it's kind of a legacy system, but we all typically still have 10100 copper, 10100 links available to monitor. I also want to note that since there really isn't a zero delay technology in the industry for gigabit copper, it's important to look for kind of like a link fault detect. So what I mean by that is if you're looking at gigabit copper products from a tap perspective or putting that device in line and you don't have something like link fault detect technology built into it, if one of my devices goes down, the other one has no idea. It's just going to keep sending right through. And it's essentially, eventually it will stop because it's going to have higher layer protocols that are going to kick in and realize there's something wrong. However, it's generally a lot longer than you want to see your network down for. So just keep an eye out for zero delay. And again, I'll mention zero delay a couple times throughout this tutorial. So we all know that hubs are cheap and easy. I kind of like to refer to hubs, and hubs are an easy way to gain access to all the packets that your device is, essentially connected to a hub. Everything's going to go through that hub. Problem I have with hubs is the more utilization you have going through a hub, the higher the collision count. It's not going to retransmit those collisions, so you're not gaining 100% full visibility of your network data anyhow. So you've gone through the motions, you've got this monitoring tool, you're plugging it into a hub because that's what's available. It's, again, cheap and easy. But you're losing data. You're not seeing all of the data to make good decisions on what might be going on because you're losing part of this data. So, and I generally see it as a point of failure. We could put devices in line as well. And that's really going to work in the sense that now you're going to preserve that full duplex link and you're going to have layer 1 and layer 2 error visibility by putting the device in line. But what happens when you have to relocate that monitoring tool? Perhaps it's not a monitoring tool that's dedicated to that link. I have actually personal experience with this because I worked with a network engineer. I won't say any names or companies in a previous life of doing some work with them, and he actually put a monitoring tool in line. And I got a page, probably a nice Saturday evening, late Saturday, and he was stuck. He was stuck with the device in line. He had placed it in line. The link essentially failed because the device failed. The NIC card, in fact, failed in the device, and he was stuck. And actually what I did was I sent him a tap, because at the time I knew that a tap he could put in line and he could gain access to that data and remain passive. And he probably kept his job too. We can also use span ports. Span ports are a great way to gain access to data by using, you configure a span port. We do it all day long. We get access to the data we want internal to the switch. It's great for data that never leaves the switch fabric. I mean, that never traverses a link that you can actually get to. But the simple fact is you lose layer 1 and layer 2 errors when using span ports. Some may not necessarily find that as a bad thing when you're using security tools and you just want to gain access to data, say for a short project. It's a viable solution. But again, when you need full visibility or dedicated visibility, you cannot run the risk of dropping a single packet. Hubs inline, putting the device inline and running the risk of link failure, or using span ports and putting an extra load on your switch and having that configuration, going through the motions of and resources for configuring it, is maybe not necessarily the best solution. It's still a great solution though. In fact, you will find several passive access or tap technology out in the market specifically designed now for span ports, because span ports aren't going to go away. The biggest thing I really see with span ports is contention. You finally get that visibility and you get that access, and now the security team wants it, the network team wants it, somebody wants it for some other tool. There's always more and more tools, and they're fighting over it. I've actually been on calls with a particular university where it was, well, he kicked my tool off, so and they're actually going back and forth on the phone about who can have the span port when, and that just seems unnecessary when there is technology out there to alleviate this contention. How are we doing so far? Does anybody have any questions? Okay. The ideal solution really became a tap, because we've just seen what other products or what other technologies, hubs, putting devices in line, and span ports can do for us and get us visibility. But there were some inherent issues with doing that. The nice thing about a tap is that you put a tap in line once. It goes in passive. You're seeing all your lower layer traffic just as if your device was sitting on the link in line. But now you're preserving that full duplex link. And the tap is device neutral. You should be looking for taps that are device neutral. If somebody tells you you have to have a tap specific for, for a specific topology, and it can only be used, now I'll argue that with fiber and LED versus laser and stuff like that, but that's another session. But you shouldn't be nailed down to a monitoring tool to a specific tap type. Taps will remain passive in the network by not introducing that point of failure. And in the event of a power failure in a tap, and just FYI, fiber taps, and we'll talk about this a little more a few slides down, fiber taps don't even require any power. So if you've got a vendor out there that's saying, yeah, I've got great fiber taps for you and they have dual power, there's something wrong there. There's certainly needs out there, we can get into regeneration technology that's got a fiber, internals, and rightfully so should be powered because there's a lot more going on inside. But a standard simple port fiber tap would not require any power. It's just splitting the light. It's just light. Taps also fail open to the network. So again, we talked about relays earlier, about that link zero delay and that link fault detect. They should always fail open to the network so that if you lose power, you lose, on a copper device that is, you are not going to take down the network link. So let's really look at this data flow of a tap. We talked about it being a permanent access port and really getting you full duplex visibility, never really interfering with the data stream. Now, depending on whether it's fiber or copper, it's going to be done a little differently. If it's copper, you're going to generally you'll see some sort of regeneration technology used to transmit that inline traffic to the monitoring device. If it's fiber, again, it's just light, and it's splitting the light to the monitoring port. So, and it's an important point that I want to make on this slide, because as we progress through this tutorial, you'll see several different output styles. If you pay close attention to the monitoring device section here, AB, you'll see that there's two output ports. It's only transmitting data. There is no way to send data back through a simple type of tap or a passive access tap. So there's no way to introduce errors. It's very safe to put on your network. There are basic tap types that I want to make sure you're familiar with, so when you go back and you're looking at, hey, maybe I will deploy some passive access taps in my network. Where do I start? And that's really why we're here today, is to tell you, arm you with information and give you as much information as we can about the different options that you have out there in the market when it comes to deploying passive access technology. A single tap, and I'm going to use some terminology here that, again, you'll hear me reference throughout the tutorial. A single tap I refer to as kind of a one-to-one. So I look at a single tap as one network link and one monitoring device. Nothing more, nothing less. Very simple device, physical layer. Going to have just one copy of data. A regeneration tap, I look at as a one-to-many. So now, and this is where contention, this solves that contention problem, whether it's span or inline applications. Now you've got one network link still, but now you've got many monitoring devices seeing the same data simultaneously and still not introducing a point of failure into the network. And again, we're going to go into these in a little more detail, but just to give you a kind of highlight of tap types. Link aggregation taps, as you'll find out in the marketplace, combine traffic. Typically, they'll combine lower layer speeds to a lower speeds to a higher speed. So, for example, 410-100 network links to 1 gig out, or in the span case of a link aggregation, 810-100 1000 links to gig out. You're going to see some really exciting things, I think, come in the next year or so around aggregation and really making sure that you're using your monitoring tools effectively and getting that return on investment, and making sure, if you've got legacy systems, you have a way to access it with your new tool set. Because we know we always like to have the latest and greatest tools. Matrix switches are a little bit different in the sense that there's a software-controlled access. We like to say software-controlled access to multiple links. What does that mean? That means I've got a lot of network links, and I've got to figure out how I get visibility to these network links with one common monitoring device. I'm always going to use this device. I'm going to leverage this device. I can't dedicate a device all the time to each link. So a matrix switch offers you the ability to change channels and view them, spot check them as you see fit. There are other taps that you'll find out in the industry, such as built-in media conversion or converter taps. The key thing about converter taps is it really serves, they really serve two purposes. Connecting to similar interfaces without a separate media converter. Now, I'm not a big fan of putting media converters in line on a link, because media converters are never passive, and if they fail, they're just going to take your entire link down. So there's got to be a way to still gain access to that data passively, but now do some conversion in there. So, for example, if you had a gigabit fiber network link and you had a gigabit copper monitoring tool, I don't really think you're going to want to go out and buy a gigabit fiber monitoring tool for maybe one link, or perhaps it's the reverse. You have options. Look at those options, whether it's fiber, copper, ZX to SX, whatever it may be. There's a lot of different converter taps out there. Active response is really the ability to, I really see active response as kind of bundled in the security arena with IDS systems, where you need to have the ability to inject data back into the network. So it's TCP resets, kill commands. You see something, hey, I got to get rid of that. I got to stop it now. I need to inject data. We've talked about taps being passive and gaining passive access and making sure that you never introduce anything back into the network. But now here we are saying active response. Well, there really is, a unique requirement for it in its rightful place. You may not deploy an active response device with a protocol analyzer because, well, you can get things back out into the network and cause problems. So just be aware that these are some of the tap types available. media conversion, converter taps, active response functionality, essentially it'll inject any valid Ethernet frame back into the network. It should. So when you're looking at active response functionality, you're going to look for something like that, and it should be sending to both sides, not knowing which side it's coming from. So we're going to jump into more detail about different taps and different interfaces. So copper tap devices are generally available. You'll find them out in the marketplace available in 10100 copper and gigabit copper, and then triple speed. It's kind of the new thing going on. Everybody's got to have triple speed, and it's cheap. Why not? So you'll find triple speed copper taps available now. Now, gigabit copper taps that you'll generally find out in the industry are going to be topology specific, so they're not going to scale down to 10100. Triple speed taps, you'll notice that all of these here are still providing you with 2 output ports. Each output port is comprised of half of the full duplex conversation on that link. So you will need 2 monitoring NICs in your monitoring tool to see that full duplex data. Perhaps you need to do some binding, but you're going to get access to the full duplex link that way. I think it's important that you look for triple speed taps with some sort of dip switch functionality. You may want to lock the speed and duplex down. You may want to leave it in auto, but you also may want to lock it down on critical links. So it's important to know your options and to know that when you're looking to deploy a triple speed tap, you have options out there with dip switches, active response, and so forth. Gigabit copper taps, I mentioned earlier about that link fault detect, making sure that the device really has some sort of fail capability, so if one end fails, it's going to know to tear down so that an alternate path can be taken if available. On the flip, there's a lot of fiber taps that you can find that we have access to, whether it's gigabit, fiber, ATM, OC3, OC12, 10 gig, all the flavors, single mode, multi-mode, 50 micron. You're going to be exposed to a lot. I mean, you probably already are. You're saying, which one do I order when I go find this tap vendor? You'll still see that there are 2 output ports for full duplex visibility. So we're going to talk about some aggregation here in a minute, where I think you'll be really excited to learn that you don't always have to deploy a device in line, or deploy a tap in line with a monitoring tool and use up 2 ports. It can be rather expensive that way. There's two choices really to make when you are looking at deploying fiber tap technology. And those are really the network topology and the split ratio. So what I mean by that is, if it's a gigabit link, put a gigabit tap on there. And the split ratio, the simplest way to think about a split ratio is the distance on your link that you have on your link and the amount of light that you're willing to bleed off to the monitoring device before you corrupt your end data, end-to-end path. So there are several factors to look at when determining a correct split ratio, and generally you'll find tap technology, fiber tap technology specifically, available in split ratios of between 50-50 and 90-10. How many of you are using some sort of fiber tap technology where you are, calculating your split ratios or you're confused about how to calculate split ratios? Nobody? Okay. Awesome. So split ratio essentially, like I said, is the amount of light you're willing to tolerate giving up on the network link. The way you generally will calculate a split ratio is again by looking at your end-to-end distance and coming up with this loss budget or this power budget. It's really the attenuation that you have on the link, cabling distance, network distance, patch panel interconnect splicing. All of those things factor into how much budget you have or how much attenuation you already have, because by the insertion of a passive access tap, you are adding to the existing line loss on the network. So there are several things that, you know, you factor in. So if we took a look at a device in line between two end devices, and we put, say, a splitter, a 7030 in there, and let's just grab gigabit multimode because it's popular and it's easy. You've got a typical launch power and you've got a typical receiver sensitivity in, you know, with your transceivers. You subtract those out and you get this magical number that becomes the number that you don't want to go over. You absolutely do not want to go over this number, or you run the potential risk of corrupting your network data, or just never getting it out to the other end. So if you come up with this magical number, by the insertion of the tap, you still should not exceed that number. The optimal split ratio is again one that maximizes your network distance but still gives you enough light to bleed off to the monitor and have your monitoring device view that data. Any questions on split ratios or how to calculate? All right. Yes. Could you could I have you go over to the mic? It'll be any minute before another plane flies by here. Oh.
Do you take into account the distance between the tap and the monitor device when you do the calculation?
Absolutely. That's a great question.
How do you take it into account?
So do you take into account the distance between the monitoring device and the tap's output ports? Yes. I have a general rule of thumb that I don't like it to exceed 10 meters, but in all reality that could be, you know, it's generally enough. If you've got a really strong signal and you're using, say, a 50-50 and it's still enough to, you know, traverse the network and be good data, and then you're sending 50% of the light to the monitor, certainly you're going to be able to extend a longer distance on the monitoring side. But again, I've probably seen it go, you know, 30 meters, 40 meters, but you are taking a lot cable losses, so you know you're still degrading the light at some point based on that distance. And if you're running it through a patch panel, I've had several conversations, you know, okay, what's going on here? I'm not seeing light, and you know, to find out patch panel, patch panel, patch panel, it's an 80-20 split. So there are there's a lot of flexibility, just depending on your overall link distance. Does that answer your question? Okay. Did you have a question? Could I have you jump over to the mic so I can hear you, please? Okay. So if you're using OC12 ATM taps, could you reuse them for 10 gig or standard gigabit? Well, there are tap-specific products, so you'll find ATM taps and you'll find gigabit taps. Most devices are manufactured and tested out there in the industry for that particular light source. So if it's manufactured, or if it's using an LED light source, it's going to be manufactured and tested for LED. If it's for laser, it's going to have a maybe an ultra polished finish or something. So there are some differences. I'd probably say if you know, if it were single mode and you stayed at 50-50, you probably wouldn't see too much of an issue. But if you started jumping between split ratios, so what is a 70-30 split ratio in ATM is not a 70-30 split ratio in gigabit. If it's multi-mode, OC12, I probably would not use it in a gigabit link, no. I would look for an ATM specific tap. Any more questions? That kind of answer help you with that? Okay, perfect. So we've been talking about the different types of taps that are available. Converter taps being a way to take dissimilar topology, or I shouldn't say topology, should say interfaces, because it's all gigabit, for example, and copper and fiber. Oh, we have another question. Well, you're putting the tap in line between your two end devices, and certainly, if there is a concern if it's 200-meter link and you're putting the tap all the way, 10 meters on one side and 190 on the other, and perhaps you don't select the right split ratio. In all reality, I mean, gig multi-mode, a pretty good general rule of thumb is 70-30. I've seen in the industry. It's been pretty successful. Certainly if your devices are sitting in the same rack, anything from a 50-50 to a 70-30 is going to work just fine. Well, I don't know if I would go that far, but I mean, certainly depending on the, you have to take a look at your overall link budget. Yeah. Yes. Absolutely. It doesn't have to be a 70-30. You can have a 50-50. Generally what you'll find is 50-50 to 90-10. On the same tap, no, it's fixed. Once it's, generally what you'll find is once it's built that way, it's going to stay that way, and you have to go out and buy another tap. All right, so where were we at? Converter taps. Let me get you guys back to converter taps. So I really see converter taps as a way to take advantage of your existing tool set. Again, with those dissimilar interfaces. So for example, here we've got a gigabit copper network link, but we've got a gigabit fiber monitoring device. Now how do we gain access to that link? There are a couple different ways. Spam port again. But if you want the lower layer errors and you want to look like, you want to see everything as if you're sitting in a line, a converter tap is a great way to go because it gives you the best of both worlds. It gives you internal conversion and passive access visibility. The thing to note with converter taps is the front end. So say, for example, on all fiber, the front end is passive. I mean, it's an optical front end, so you can't really bring the network link down with a power state change or anything of that nature. You will find these powered. So it's important. I think it's important anytime you're looking for devices. I'm sure you guys do this with all of the network equipment that we deploy. Some sort of redundant power or something, and you'll generally find all of TAP products out there with some sort of redundant power. It's been turned into the norm, I think, over the last 5 years or so. You'll find a lot of different converter taps, in fact. So say, for example, you had a gigabit ZX link and you needed to monitor it with copper. You'll find a converter tap available for that. If you had a gigabit copper link and you wanted to monitor it with a gigabit single mode monitoring device, you'll find a copper tap for that as well out there. So there's a lot of options out there. Don't think you're necessarily locked down to looking for an alternate way or settling for putting a media converter in line or something and running the potential risks associated with that. So up to now we've been talking about some taps. We've shown you these double arrows out, still passive, no way to bring data back in. So now we're going to talk about the benefits of aggregator taps, essentially. Instead of requiring two monitoring NICs in your tool to see one link full duplex, you can deploy something that's generally referred to as a port aggregation tap out in the market, where you now have a full duplex link still being tapped, still passive, physical layer device, but now internally it's aggregating, it's consolidating this data and coming out one interface, whether that be copper or fiber, whatever the interface may be. So this really allows you to take advantage of your monitoring tools, because now you may have tools that have 4 NICs, so for example. Whereas previously you may have been able to look at up to 2 links. Now you really can do a 1-for-1 and look at 1 link with one NIC. It's important, I think, as well to find port aggregation taps that have, again, those dip switches I talked about earlier. Some, whether they, you know, you'll find different terminology for it. I call them dip switches because that's what I'm used to. Essentially, you need flexibility. You need a way to, again, lock down the speed in duplex or leave it set to auto. You'll also find port aggregator taps with that active response functionality. So not only is it combining the data out one interface, you can make that port a 2-way full duplex active passive port. So there are a lot of options out there for aggregation, and I only see more coming. So let's take a look at a port aggregator tap sitting in a network link, a simple network link, a router and a firewall. In line, the end devices are communicating through the tap ports, generally in like 10100 copper. In gigabit copper, you'll find end devices will generally negotiate a link with the individual tap port, and that's where that link fault detect feature is really important to have. But in 10100, it's like the device isn't even there, and devices are talking to each other. And now your monitoring device is seeing that full duplex data stream. So all along we've been talking about this single output port. Life's great, we've got taps in line, but now we need multiple output ports. We need a way to have our security tools, our protocol analyzers, our Armon probes, all the tools that we've invested in, potentially seeing the same link, because they certainly have different purposes. That's where something like a regeneration tap will come into play. Regeneration tap essentially gives you access to that single link. We're still talking about one individual link, and now that one-to-many I mentioned earlier in the tutorial, now we're talking about that one-to-many. So one network link, multiple monitoring devices. You'll see regeneration taps available in 10100 copper, gigabit copper, span inline, fiber. So again, that OC3, OC12 topology specific when you're getting into the fiber stuff. And then gigabit as well, and 10 gig. That's like the latest regeneration technology hotspot right now is like, 10 gig. So I'll look for those of you who are running 10 gig links. You still have access to that data with multiple monitoring devices. Any questions? I'm doing okay? Good. Thank you. Span regeneration taps are a little different than inline regeneration taps. So inline, we're sitting on that link, full duplex. Now a span regeneration tap, you essentially are hanging off of a span port, and you still need access to that data. You've gone through the trouble, you have the span support session set up. Now everybody wants access to it, and that's exactly what a span regeneration tap in the industry will do for you. I refer to it as a dual span, and here's why. Because if you see, there's still 2 sets of data flow. So you could have 2 separate span sessions come into a span regeneration tap specifically, and be copied and sent out to up to 8 monitoring devices. So now you have, and they're not aggregated. They're independently being copied across the monitor ports. So you have the ability to have 2 separate span sessions be monitored with your tools. Contention generally. I have a lot of, at the core, a lot of span sessions going on where you want to monitor the data. set monitoring devices dedicated to that. So you want to at least get mostly, security tools, and then a protocol analyzer or content filtering, further out in the network. So there are a lot of various deployment strategies for span regenerations, but I generally see them as a method of reducing that, contention. Everybody needs access. So that's kind of, the solution seems to be span regeneration taps. And a typical deployment of a span regeneration tap would look actually something like this. So you see you've got multiple switch span ports available. You can bring up to 2 to a span regeneration tap and send it out. So we're going to wrap up section 2 where we talked about taps, aggregation taps. So taps being one-to-one, they're inexpensive. The only disadvantage I've actually seen to tap technology has been the initial cost. I don't think anybody's figured out a way to give away taps for free, so you do have to have the initial investment, but it does seem to make sense when you compare it to other methods of gaining access to your data. Aggregation taps, again, just being the same footprint or the same type of tap technology, but now monitoring via a single NIC and having the ability to have up to 2 monitor ports view that same data. So a little bit of a hybrid of a regeneration technology built in with a port aggregation technology. Key features that you want to look for would be zero delay in that link fault detect. I think are very important to look for when you're looking at copper products, and no power when you're looking at single port fiber taps. So I mentioned active response earlier, and I actually saved bypass switches, I think. I didn't say any good info on that. Active response essentially, again, is the ability to inject that data back into the network. So you can see here in this diagram here of data flow, all those front-end ports are still passive, and they should be, because there are tools that need to monitor passively, and you don't want the ability to accidentally inject data back into the network or create a loop, or we won't go there. But now you have the ability to send those TCP resets through a tap port. You can usually, in the keyword usually, disable active response on tap products. So when you're looking at, again, when you're looking at deploying active response, it's something to pay close attention to, because it does give you the ability to put data back out onto the network. So, pay close attention to which ports are active, which ports are passive, how to disable the active if you don't want somebody to gain access. Just turn it off. And we won't go there. So bypass switches, I think, are the hot new thing right now, because IPSs are really hot right now out in the industry. Everybody's deploying IPS systems, and the vendors are telling you to put them in line. I need to sit in line. The data's got to go right through my device so that I can make those intelligent decisions. And we talked earlier about putting devices in line, and probably the key thing to take away from that is that it's a simple way of to put a device in line. It's simple to do, but it's a big point of failure. You really run a risk of bringing your link down, and you lock the device down. From an IPS standpoint, you want to lock the device down generally to that link. So you'll look for products out there typically referred to as bypass switches. Bypass switches are a means of fail-safe link protection. When you're putting your device in line, the bypass switch essentially has some smarts or some intelligence to know whether or not your IPS is up and running based on maybe power or even a heartbeat packet that flows through. And if it doesn't detect something, it's generally going to gracefully back you out of the network and stop the data from flowing through the IPS appliance, and just leave the end devices alone as a passive link. So you see here in an enabled mode and a disabled mode how the states change. Bypass switches are generally available with some sort of heartbeat packet. When you're looking at, say, a bypass switch with heartbeat, some sort of IPX or, TCP packet structure. Really, you should be able to configure any type of packet in a bypass switch. And really all that needs to happen is that IPS solution needs to be able to receive this heartbeat packet and then just send it through. The bypass switch is going to see its own packet and know that the IPS is up and running, thereby leaving it in line and having the data flow through the IPS system. It is about, it's fast switching, certainly, and if I had to think back, I'd probably say, 10 microseconds is probably the typical switching time. It's usually configurable. You want to look for options in a bypass switch. So when you're deploying it, you want to know, hey, can I configure any type of heartbeat packet, or do I have to use the standard one that comes with it? And what are my options? What do I have available? Can I configure it for, 1 second? I know from experience with, these bypass switches that the default will be 1 second, and if it doesn't receive 3 heartbeat packets in a row, it will go into bypass mode. But again, that's configurable. There usually is some sort of hyperterminal port, an RS-232 port that you can hyperterm in to make changes. So you want to look for those types of that flexibility rather when you're looking at bypass switches. You should also look for bypass switches that have been tested and certified with their vendors, the vendors that you're deploying. A lot of them out in the industry, they are tested and certified with the vendors. So, but again, it helps to know that two entities out there have taken the time to make sure the devices are compatible with each other. So you don't figure it out for them. There is also another type of bypass switch that's out there in the marketplace that you probably should know about, so that when you're looking at these, you have some sort of comparison data, and that's a power-only bypass switch. Honestly, I generally see the heartbeat ones as being, the way to go. It's got some smarts. It's going to know it's sending that heartbeat packet. But there is a power-only, and the assumption there is that you would connect the IPS appliance to the same power source as the bypass switch. So you can pretty much, equate that to, if the bypass loses power, your IPS probably lost power too, and so it's going to fail over to the network. Not as popular though as I see. I see the heartbeats definitely more popular out there. So again, a disabled mode, data is flowing through the IPS system. And in an enabled mode, data is no longer flowing through the IPS appliance. Data is only flowing through the network ports or end-to-end, bypassing that appliance so that it can be removed and upgraded, fixed, replaced. So some things I hope you take away from this section are the data injection capabilities that you have available to you in aggregation and regeneration tap products, power-only versions of bypasses when you're deploying your IPS solutions, and heartbeat versions of bypass. You'll generally find bypass switches, fiber and copper. There's even a conversion bypass switch out there. So people are getting smart and realizing that, hey, I can just consolidate this too. So a lot of options available. Any questions on bypass switches or active response? Okay. So again, up to now, we've talked about taps, different access methods to one link, dedicated monitoring devices for those links, IPS systems that need to sit in line. So how do we do that nicely, gracefully back them out when they need to be? So now there's really a need to maximize your monitoring tool set and leverage your assets of tools that you have invested in. So again, I mentioned earlier link aggregation taps, where you have the ability to take multiple network links and consolidate them down to one output. Really effective for, that I see right now, with 100 copper and then gig out. You have a lot of options: fiber, copper out, 1 or 2 monitor ports out. But generally that's the type of link aggregation that you'll find in the industry. So inline link aggregation would look something like this: taking those 4 100 links, consolidating them internally, and coming out 1 or 2 monitoring devices. And again, whether that's copper or fiber, it's usually up to you. You usually, will have options from the vendor. There's also span link aggregation taps. They're generally 2 separate devices, because in an inline link aggregation, you're employing that tap technology. So your front end is passive and has this internal taps. Span is more of a, just an endpoint. And the cool thing about span link ags that are out there is that they're 10, 100, 1000 generally. There's not a lot of fiber link aggregation out right now. There's a big push to get fiber link ags out in the industry. There's a big need for it. Generally, what you can do with copper, you want to be able to do with fiber. So the natural evolution is to get span link ags out in the marketplace, which I'm sure everybody will be coming up with soon here. The important thing to note on a span is that, again, it's 10, 100, 1000. Data flow is, straight, all your span connections. The other way I see link ags deployed, usually, and I say link ags, I really mean link aggregation, it's just a longer word to say, is by taking output ports of existing passive access taps you already have deployed into the network. So can you see how you can have passive taps in the network and then take the output ports of those, say, an SX to TX tap, for example. So that's a conversion tap that's gigabit fiber to gigabit copper out. 2 output ports, each is half. Running a bunch of those into a span link aggregator and coming out gig. Now, of course, you have utilization things to think about. You never want to exceed the 1 gig out. However, there are additional uses for link aggregation taps out there. And this is a great case study in that I wanted to share with you, because this is exactly what I worked with this customer on. I worked with this company and trying to figure out a way for them to get access to primary and redundant links. And this is a scaled down version. Several fiber links. Monitoring tools were copper. And this is, again, scaled down on the copper monitoring tools. I think there was something along the lines of 7 or 8, maybe. So the need was, their requirement was to take several output ports of existing or, of these taps and bring them in to an aggregation point to consolidate them down. The utilization on the links was low, so it wasn't an issue. And then from there, they said, well, that's great, but I need to have all of these monitoring devices view that data. So I said, okay. And here's a regeneration tap in the picture now. So now you can kind of see how you don't have to just look for one particular type of technology to fit the bill for your deployment. You can look at several types of technology and marry them together for that complete system that you're looking for, whether it's aggregation and regeneration, or it's simple aggregation, or simple regeneration to multiple monitoring devices. So here's those matrix switches where we said we're a little different. And that matrix switches really give you visibility into multiple network links with those common monitoring tools. There's inline matrix switches out there, and there's span matrix switches. We're going to talk about inline first. Inline matrix switches use tap technology again. So passive on the front end. So now you get that cross-link visibility without having to, with that same monitoring device, without having to, expand your budget and go buy more. The latest technology in matrix switches actually is, because, of course, with passive access technology, you always want it to be passive, transparent, so thereby your monitoring devices are transparent. But the next move on matrix switches is Ethernet ports, SNMP traps, sending traps to your monitoring, to your Tivoli or HP OpenView for specific stats. So that's something that I see new in the industry of matrix switches. For the most part, they're very simple to deploy because they are a common central monitoring point. So you're cabling up all of these links to one common device, and then you're taking your monitoring tool and you're connecting that in, and now you have the ability to look at several different network links as you see fit. You'll usually get software with matrix switches. The vendor should be giving you software. Or, again, that IP addressable type of unit that you can access via a web console or something of that nature. If you don't see that on there, then you want to know what kind of software am I getting with this matrix switch and what can it do for me? Can it just monitor one? Do I have to connect, multiple monitoring devices? So say I have a matrix switch that allows me to have up to 4 monitoring tools. They're out there. Each monitoring tool should have the ability to change to a link as you see fit for that monitoring tool without ever really having any dependency with the other monitoring tools. So some definite things to look for. You should look for, I call it roaming capabilities. You can change channels all day long, but if you can set up a software to change channels for you, why not? That's great. I mean, that's automation, and there is automation built in matrix switch software out there that will allow you to set the channels, view them for individual, time periods, customize the roaming. So perhaps you only want to look at one link for 10 minutes, but you want to look at the second link for a half an hour. You should have that flexibility in your software that's controlling a matrix switch. Again, inline matrix switches still considered a physical layer device using tap technology. So the front end is still passive. An example of a matrix switch in this particular one has 2 monitor ports. So now you can get visibility. You can see how you can get visibility into several links, and you choose which ones you want to monitor. And because it's using that tap technology, it's seeing the same data as if your monitoring tool were sitting in line. Span matrix switches essentially give you access to multiple span ports. So you think about an inline, you have access to multiple network links. A span, you have access to multiple network switch span ports. The cool thing about span switches is, if there is if you can even say cool and span switches in, I guess, the same sentence, there's daisy chaining capabilities that you should be looking for with span matrix switches. So most of these devices you'll find, you know, like, let's say, for example, inline. You'll find them in, like, nobody ever really wants to go too high in a port density in an inline matrix switch, any of the you know, passive access vendors. So you'll generally find like an 8 and a 16 port. So the highest you're going to be able to get up to is 16 network links. But that's great because it saved you from buying 16 individual monitoring tools for that one purpose. Now span works a little bit different in that because you're just coming off of a span port, you're not doing any tapping, you can actually get about up to 96 monitoring span port visibility with span matrix switches by just kind of chaining them together, having a master slave configuration, and then having your monitoring tool and that software or that remote access capability to look at up to 96 channels. Since span matrix switches are coming off of a span port, obviously they don't have any tap technology. They're more of that end station type of monitoring solution. An example of a span matrix switch application would be coming off of several switch span ports, bringing them in again to that one common hardware point, and then monitoring them as you see fit through the use of software. So another really interesting case study was existing regeneration tap technology on the network links. And there were several tools in this particular case. There were intrusion detection IDS systems that were hanging off of these, were dedicated. And then there was the need to take a common protocol analyzer, essentially. I'm not even going to say monitoring device anymore. Protocol analyzer, in this particular case, to view those different network links. So the logical thing to do was to take the output ports, one set of output ports from a regeneration tap, and chain them into a matrix switch. And now you've got visibility at all of those points. You didn't have to tear out the other passive access solutions, throw them away, go buy other tools. You're using them together and really building on your access solutions. And I generally see matrix switches used with protocol analyzer and Armon probes. I've never really seen a, I guess, good or true requirement in the security arena because usually you have to see all the data all the time. You can't necessarily pick and choose. It's all or nothing. So to summarize the matrix switches and the link ags, link aggregators, you're going to have the ability, you should have the ability when you're looking at link aggregation technology out there to have up to 8 span sessions to 1 gig out, or up to 4 10100 full duplex links to 1 gig out. And matrix switches, you have a lot of flexibility in software features. Inline matrix switches using that tap technology, span port matrix switches using or having a daisy chain features. And then the software, again, is key because you want to make sure that software that you get serves your purposes of monitoring and roaming across those links. So, having said all of that about passive access products, there's a whole new set of products that are evolving in passive access technology with intelligence and remote access capabilities. As you think about deploying a tap, how are you going to get to the tap to, say, maybe turn off the monitor port, see how high the peak utilization was at any given time? You can't because it's an extremely passive device, and there is an absolute need for passive devices, but there's also a need for intelligent passive access taps so you can gain access to this information. You can look at, and taps actually, these new style intelligent taps will usually have a display screen on the front of them. So if you are in the data center and you're looking through, you can see the utilization rates for side A and side B. You can gain access to the taps and look at them remotely, and you can also turn off the management port that you use to gain access, so don't lock yourself out. But you can also turn off the front panel display. Say you didn't want that information going on the front panel in your data center. You can disable that as well. So there are a lot of features that intelligent taps have that you won't find in just a standard passive access tap. Again, two separate deployment strategies. One, extremely passive. I don't need to know anything. I've got my monitoring tool. I'll find everything out there. Or two, intelligence, and I want to know where to best put my monitoring tool. So give me some information so I can move my monitoring tool around maybe. Because before an intelligent passive access device came out, you probably did, move an entire monitoring tool, set it up, get it working to find out, oh no, this link's doing okay, it must be another link. So there's, obviously we know that there are several other ways to gain access to that information, but the ease of use, again, it's still serving as a passive access tap, but now just giving you additional feature sets. I'm a page down. So real-time utilization levels for each side of the link. So if you set a utilization level of 64% and it exceeds that, you want to know. You want to know what happened that exceeded the threshold that you put in. You have that visibility now. I mean, the tap was sitting there with all the data running through it anyhow, so why not take advantage of that opportunity to give you statistical information. You'll have SNMP traps for system, link, power, and that threshold that I was just mentioning. And those traps can be sent to, collector engine. Counters for total packet type, so you'll know exactly what's running through, how many CRC errors there might have been on the network link, any collisions. And again, you could turn off the LCD information, reset statistics. A lot of options available in intelligent taps that you will see emerge over the next several years. Primarily coming out now and available to you now, but I only see the feature set growing. Does anybody have any questions on the intelligent tap versus the passive tap? And sure. Well, that's a good question. So how many companies out there are offering intelligent tap systems right now? That I can think of, one. But it won't be long before there's probably many. It never is, right? So to summarize on the taps, intelligent taps, you can really start to baseline information from the tap to know where to deploy your monitoring tools. And again, giving you access to the data, still passively, but with more information and more smarts, so that you know where to put those tools, you know when something's wrong, and you can respond to it. I'll tell you another story about an intelligent tap deployment, but you're probably tired of my stories. And that kind of wraps up our fundamentals of passive monitoring access. I really want to thank you guys for sitting here and, God, learning everything, or listening to taps and passiveness and being aware of zero delay and active response. And I just wish, I want you to take away that you have options. There are a lot of tap products out there. Know your options and and select the right product for your deployment. And if you're putting your devices in line, don't anymore. Thank you.